All right, everyone. So I'm going to do something like this today. Rather than teaching the chapter, I'm going to show some tricks how to do the molecular structure. Yeah. So one of the laboratory, I think lab 13 or so, you need to do something like this. So we just practice those kind of things here. Yeah. So let's write something like uh, a molecule that has, let's say, the center, it has carbon. So this is a carbon atom. And with this carbon, 4 hydrogen atoms are attached. So there is one hydrogen, here is one hydrogen, here is one hydrogen, and here is one hydrogen. So 4 hydrogen attached with a carbon like this. So this is CH4. This one is C, this one is H, this one is H, this one is H, this one is H. The CH4, right? So it looks like this in the, when you draw it, but actually this one is not like this. So if you look here, the angle looks to be the 90-degree, right? So your high school math is now is 90-degree, 90-degree, 90-degree. But exactly this molecule is not like the planar like this. So if this is a carbon here, so this my hand is a carbon. So I'm going to hold this like this. So you see this one, this is coming like this. So this one is like this. Make sense? Now I'm going to hold this one and this way. And then this one is this one. So this is also coming toward me, right? Make sense? And then I'm going to hold this one and then like this, and then it's going to penetrate this board and going away. So this one is that one. Make sense? And I'm going to hold this one. So I want to penetrate this board and hold like this, and this is going the other way. Make sense? So this one is coming to hug me, and these are going away from me in the board. So that's the CS4 molecule. Yeah. So if you look like the CS4, so that looks like this. So these are going away from the board. These are coming toward me, or you can say these two are coming toward me like the arms extending toward me, right? And then this one and this one are going away from the board. Yeah. So how do they write is that if to go away from board, so something like this. So sometimes they write like this. So that's going away from the board, or this one is also going away from the board, and these two are coming. They like, so the Wiz formula. Yeah. So something like this. So think that these two are coming toward me, these two are going away from me, and this is in the board. Just how I hold those four this marker, right? Good. So all molecules look like this: CS4, CCl4, anything. So you think something like attached with the C. So what else? CF4, CF4. So all molecules look like this. Yeah. So this is called a three-dimensional structure. So this is not 90 degrees. So if you really measure the angle between these atoms here, it's 199 degree, 190 degree. So 109 degree is the most stable molecule. If you see somewhere at the center one atom and there are other atoms attached, and between these peripheral atom is, if the angle between those peripheral atoms is 190 degree, that is the most stable structure. Yeah. So 190 degrees is the most happiest molecule in the world if there is those angle between those peripheral atom is 190. Yeah, good. So that's like this. Now, so this is the basis of everything. So if you know this one, then you know everything. Yeah. So let's do something like this one. So when you go home and then look at lab 13, and then you start to do that, and it makes sense. Yeah. All right. So let's write like this. So I'm going to write the water molecules. So we'll discuss this in detail later, but I just want to give the flavor here. So water molecule. So the water is in center like this. So this is oxygen. So oxygen is at the center here, right? This is oxygen. Now there are two hydrogen. One hydrogen is this way. And sorry, I need to put a little smaller. So this is hydrogen, and this is another hydrogen, right? So two hydrogen are attached to the central oxygen, right? It's just like this. So I have a hand here. So this is a oxygen, and this is a bond, and this is a hydrogen here, right? The cap is a hydrogen. So I hold another like this. So like just like this. You see that? So this is water molecule. So this is a hydrogen. This is a hydrogen here. So this is a force, a bond, 2 electron. This is 2 electron, and this one is a oxygen like this, 3-dimensional, not the plane or circle like this. Yeah. So, but water molecule is not like this. It looks like the 180-degree, right? So if you measure this angle, it looks like the 180-degree, right? But water molecule is not 180-degree. What happens is that this oxygen, so this central oxygen has 4 extra electrons with it at the valence shell. We'll talk later. So those 2 electrons sit like this here. So 2 are here and 2 are here, like this. Yeah, there are 4 extra electrons with this oxygen there, and this. So you may think that okay, these two hydrogen. So this is hydrogen, this is hydrogen, this is oxygen. So this hydrogen and this hydrogen are coming toward me to hug me, right? And then this electron and this electron are one is going, both are going away, or this kind of thing. So, how I drop previously. So I was saying something like this. So this is carbon, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. So I told you this and this are coming toward me, this and this are going away from me, right? Exactly, you can think something like this. So what happens is, so when we draw the structure in planar, this plane board is a little bit confusing. Yeah, we need a model, 3-dimensional model. So in this case, you are thinking that okay, this is a 180-degree linear molecule, but it is not a linear molecule. What happens is that this electron and this 2 electron and this electron repel with each other. This repel this one, this repel this one. Yeah, and this also repel this one, this also repel this one. So there are also 2 electrons. So this bond means there are 2 electrons here. This bond means there are 2 electrons here. So something like that. So this is repelling this one, this is repelling this one, this is repelling this one, and this is repelling this one. So all electrons are repelling each other in those pairs. Make sense? And what happens is that the repulsion is maximum between these free electrons, lone pair electrons. So this and this repel with too much force. Yeah? And this one and this one are not that free, so they don't repel that much. But this one and this one repel more, this one and this one repel more. So what happens is that the free electron and free electron, so they call lone pair and lone pair. So they call this free electron lone pair, yeah? Meaning lonely, they are just sitting there doing nothing. So lone pair repulsion is very high. So very high. And then this is called, this is again lone pair, and this is called bond pair. So there are 2 electrons in this bond, there are 2 electrons in this bond. They call bond pair. So lone pair and bond pair, the repulsion is high. It's not very high. It's only high. Make sense? It's high. So this one is these 2 electron and these 2 electron are repelling with a very high force there, right? And then this one and this one are also repelling. This one and this one are also repelling, but that force is not that very high. But I just set the high, right? Now the repulsion between this one and this one is not great. So the bond pair repulsion is low. Bond pair repulsion is low. So this is called the Vseprt electronic theory. VESPR. Valence electron VSE. Valence shell electron repulsion. Valence shell electron pair repulsion theory. So VSEPR. Yeah. So this is called that one. So this one is pushing with a great force. This one is pushing with great force, but not is that high there. And this one are pushing a little bit less force, right? So what happens is that, so this electron is going to push this 2 electron down, and these 2 electrons are going to push it down. So what happens is that it becomes like this. So oxygen was here. This guy is pushing this down. So this comes like this. So this hydrogen comes like this down, and this hydrogen comes like this down. Make sense? Why? So water molecule is exactly like this. You would think that okay, water angle between hydrogen and hydrogen in water molecule is 180 degree, but it is not. It's about 105 degree, 104 or 105 degree. Make sense? So why it happened? Because oxygen has a 2 lone pair. The lone pair, the force of repulsion between the electron is ordered like this. So this lone pair are pushing this bond pair down. So the water molecule is just bent as a V shape. It looks like a V. Yeah. So like that. Make sense? So these electron calls are very important there. Now water looks like that. Now, So we just use this theory all the time, yeah? So now let's look another one, the carbon dioxide. So I use the carbon dioxide. Carbon dioxide. So carbon, oxygen here, oxygen here. So this guy, this carbon doesn't have any electrons. So there are no extra electron here, no free electron here. We'll talk later, yeah? I'm just trying to give some idea here. So there are no electron here, there are no electron here, only these electrons. So it's just like this one. So carbon is here. So this is a carbon, my hand is a carbon. So this oxygen is this way, right? And then I hold this one, and this is this way. And there are no electron to push this two electron down. So this is linear, yeah? So if there were an electron here like this would push this down, this would push it down, and it would be like the V shape. There is a carbon, there is oxygen. This would come down, this would come down, right? But there are no electrons, so they just try to be far away from each other. Yeah, good. Just a pushing. So now another one. Let's see. Something like this. Let's say at the center there is a atom, something like the boron. I call the boron, and this one is connected to three hydrogen. Let's say this is a hydrogen, this is another hydrogen, and this is another hydrogen. So this looks like a triangle, right? Equilateral triangle, because the bond length here is equal, so it looks like the equilateral triangle. So the angle between this and this is 120 degree. This is 120 degree, and this is 120 degree. So like the BS3, see that? So if there is a boron, and if it is connected to three atom like this, so it's just like this is the boron atom. So you hold the pen like this way, another like this way, and another like this way, and they all are in the plane. Make sense? The plane in the plane of the paper. So this is like this. Now this boron atom here doesn't have any electron, no electron, extra electron here with the boron atom at the center. Yeah. So what happens if I put the boron atom at the center? Let's put that one. So something like this. So this is if a central atom is connected to three atoms, it looks like the planar, the plane of the paper, and everything is in the board. So you have this is in the board, this is in the board, and this is in the board, and this is nothing is going away from the board or coming toward me. What I previously talked in the CS, right? Now let's talk about something like this. So we have a sulfur dioxide. So something like this. So let's say this is sulfur, and then we have oxygen here, and we have a three. Okay, all right. So like this. So again, if there is one pair of electron here, so let's say this is oxygen, this is oxygen, this is sulfur, right? Like this, right? Now you have a double bond here, and you have a double bond here, sulfur dioxide. This is sulfur, this is oxygen, this is oxygen. Now this looks like the linear, but what happens? So here is one lone pair, but there was another atom previously. There was no electron here, right? Now if there is electron here, what is happening is that this is going to push it down. Again, these two electrons are going to push they down. Make sense? So it's also bent toward like the V. So sulfur dioxide looks like this. Yeah. So if there was another atom, maybe sulfur trioxide, let's say there was oxygen, and then it was connected like this. So this would not repel that with that force. So it would be like this. Yeah. But since there was only two electrons here, these electrons are pushing this bond down and this bond down. So it just bend down. Make sense? So that's the V shape. Sulfur dioxide is a V shape. Make sense? So we have to look the electron in the valence shell, and we just calculate how it is pushing other thing down. Yeah, good. Now let's talk another thing here. So it's very good for you when you are doing the lab 13. Yeah. Now that one. Now sulfur dioxide. Now what else? I have a CS4, CCl4. I already talked it. Now let's talk about the ammonia molecule. So ammonia, this is ammonia, NH3, right? Now let's look the ammonia. So nitrogen is here, another hydrogen is here, hydrogen is here, hydrogen is here, right? NH3, right? Now if there was no electron with this nitrogen at the center, what would happen is it would exactly look like that BS3. So just like you have a nitrogen here, this hand is a nitrogen, and then you hold this one, this is a hydrogen, and then you hold this as a this way. So this is another hydrogen like this, and you hold another hydrogen like this, and it look like the plane, right? Everything is in the same plane, yeah. But so you would expect something like this, nitrogen, so something like the triangle. So this is hydrogen, this is hydrogen. So you'd think ammonia is something like this, right? Just like the VST. Now, but ammonia doesn't, this nitrogen has one pair of electrons here, like this, extra pair there. So how that comes, we will talk in the next class, yeah? I just want to give idea. So what happens is that, so this guy is pushing this hydrogen down, this one is pushing this hydrogen down, maybe this is also influencing this one and is pushing down. So all three hydrogen are being pushed down by that lone pair electron, right? So this one is pushing it down, this one pushing it down, so this is also, everything is being pushed down, right? With this, because pushing of this force is very high, yeah? So what happens is, so nitrogen is this one, right? So this hydrogen is pushed down, this hydrogen is pushed down, this hydrogen is pushed down. So from this, hydrogen was at the beginning like this. So my hand is a nitrogen. So it is pushed down like this. That hydrogen is pushed down like this, right? And this was in the plane. This was in the plane of the paper here. This is also pushed down and go like this, down. Listen? It go down like this. And this one is in the plane of the board, but this is not in the plane of the board anymore, and it also goes down like this. It's like the tripod. Make sense? Just the tripod. So ammonia molecule doesn't look like the planet. So ammonia molecule look like this. And this hydrogen is pushed down by this lone pair. This hydrogen is also pushed down by the lone pair. This lone pair, and this hydrogen is also pushed by this electron are pushed, and this hydrogen is also pushed down by the electron. And this looks like this. Ammonia looks like this. Make sense? So if there is some lone pair at the center, they are going to influence the structure of the molecule. Yeah. So the molecular the angle, if you measure the angle here, you may think that okay, the angle between hydrogen and hydrogen is 120 degrees, because this is center. The maximum possible angle around this center is 360. So you divide by 3, right? There are 3 angles. Now, but this is about 199 degrees. I think 106 degree or 107 degree, something like this. Yeah, smaller. So it is just pushed down. And then like that. Now that's NS4. The water molecule I already talked, right? Did I talk about the water? I already talked about the water. Water, you think like this. So water, I already told you. So oxygen, hydrogen, you think something like this, right? So you may think that okay, the bond angle between this one and this one is 180 degree. It's a linear angle, but it's not like that. So what happens is, the oxygen has one pair here, another pair here. So this is pushing it down, this is pushing it down, and these two are also pushing each other. So this bond is going down, this bond is also going down. So oxygen is like this. So like this, yeah. This is the water molecule. So water molecule is about 104 degree, yeah. So like this. Now let's talk another one here. So in the next class, I will show you how those lone pair and bond pair comes there. Yeah, how those electron come. I'm just talking the how the bond pair and lone pair affect the structure. In the next class, I will show you how those bond pair and lone pair comes, how we count the electron and put something as a bond pair, something as a lone pair. Yeah. Now another one. Let's see this one. You have something like this, 1, 2, 3, 4, 5. Let's say you have a PCl5 molecules, something PCl. So P is a central molecule. There are 5 chlorine, right? So first of all, what you do is, this is a P. So this is a center is a P. Now put so just like the paper. So this is a P. So you have a P here. This is a phosphorus. Now put one chlorine this way, right? And then put another chlorine this way. Now you have a 2 chlorine, right? Like this, and then put another chlorine like this way. Now how many chlorine you put? 3 chlorine, right? So in the plane. Now you need to put the another 2 chlorine, one like these are in the plane, same plane, right? This one are exactly in the same. So another chlorine you need to put like this up. Another chlorine you need to put like this if there is another. Make sense? So PCl5 and so something like this. So this is P. Now I'm going to put first three chlorine. So one chlorine is here. So another chlorine is here. Another chlorine is here in the plane, right? In the plane. How I put the one like this. This is one. This is another, and this is another. This is a plane. I just finished putting these three things here. Make sense? All right. And then one is up there. Now I'm going to put one up there here, and then another is down here, something like this. Now this is a PCl5. P, Cl, 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 PCl5 like this. But it's a little bit harder to draw in the board here. So how we draw this actually is like this. So this is P. So Cl. So this is Cl. This is Cl. So this one is a Cl, and this one is a Cl, and this one is a Cl. So we draw like this. Yeah. So this Cl, this Cl, this Cl are in the plane, the board, and this one is going away. This one is coming away. Both are going away, or something like this. Yeah. So what happens here is looks like now this angle is a little bit difficult to see. So if you see like this, so this is a P, right? So this one, my hand is a P. So I hold like this. This one is this one. This one is this one. Now I hold this another like this. You see, exactly like this, right? Now this one is this Cl. This one is this Cl. This one is this Cl. Make sense? So angle between this and this is 120. Angle between this one is 120. Angle between this one and this one is 120. Make sense? So if you cannot imagine the three-dimensional structure like this, you cannot look here and say anything. Yeah. So in the plane and this molecular three-dimensional, we need to do something like this. We need to hold like this. So Cl, P here. So the angle between this and this is 120. The angle between this and this is 120. The angle between this and this is 120. Yeah. So angle between this one is 120. This is 120. So this one is this one. So this angle between this one and this one is also 120. The angle between this one and this one also 120. I'm just talking to the plane up to now, right? I just hold the three things. So this is P, this is Cl, this is Cl. So I'm just holding these three things like this, right? So I just hold like this, and this is 120, 120, 120, 120. I have not talked up and down it. Yeah. So I put this angle, and this angle are 120. So between this and Cl is 120. Between this Cl and this Cl is 120. Between this Cl and this Cl is 120. Right. Now I'm going to talk about the angle between this guy and this guy. It's very confusing. So when I was undergraduate student, I always confused because this is a three-dimensional structure. Now I'm going to talk about the angle between this one and this one, and this one. Yeah. So let's talk about this one. So I have like this. So like this. I have like this, right? Three things. Make sense? Like this. Yeah. I am in the planar. Now where is the another angle? So this is going off like this, right? Make sense? So what is the angle between this guy and this guy? 90. Clearly 90, right? Yeah? Make sense or no? It makes sense. From this to this is 90, right? It's a straight up there, and this is a plane. So it's like you have a plane there, and there is a tree standing. It's just a 90 degree, right? So how about if I put it down? Again, the same thing. So angle between this and this one is 90 degree, right? So the angle between up and this one is 90. So the angle between this and the going down is also 90. Make sense? So this one, the angle between this guy and this guy is 90. The angle between this guy and this guy is also 90. So anything you talk about, the angle between, you see, if you see here, this doesn't look like 90, right? It looks like 20, right? But you cannot say something like this because it's a plane. I'm drawing with the molecule in the plane, right? So this is going like this, and this molecule is this chlorine is going like this, and then I'm putting another like this up there, right? So the angle between this is 90 degree. Make sense? So PCl5. So it's very important when you do those molecular modeling. Now that's like that. So let's talk another one. So all right. So this the like now let's distort that PCl5 molecule now. Now I'm going to, so what I told you, so this is a P here in the center. So this was CL, this was CL, this was CL. So they were in the plane. Maybe I write this way. So this way in the plane, and this one guy is going up here. Is up from my hand, and this is going down, and this one is 120. This one is 120. This one is 120, and the angle between this CL and this CL is 90. The angle between this CL and this CL is 90. The angle between this CL and this CL is 90. So that's what I have been telling, right? Make sense? All right. So now let's put some. So let's remove one of those from one place. I just want to remove this CL from here, and I want to put one pair of electron there. Yeah, I'm just removing one. I just want to draw the PCl4, not PCl5. Yeah. So this was previously I was drawing this. This is P, Cl, 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 Cl. 1, 2, 3, 4, 5. I was drawing like this, right? Now I want to do PCl4, not PCl5. Yeah. So I just want to remove one Cl with the one pair of electron there. So this is P. This is P. Now what I do is, let's say PCl. Okay. So I do like this. So let's put, this is Cl. This is Cl, and then this is, I just put a little bit different way here. So this is Cl, this is in the plane. So I'm just holding like the P here. P is my hand, Cl is this fluorine going like this, right? Yeah. Now PCl, another one is I draw like this. So let's say this is Cl. This is also another Cl. So like this. So one is P. My hand is P. That's Cl. This another Cl. And if I write another Cl, I would write this way, right? In the plane. Now I have two Cl here. One Cl is here, another Cl is here, right? So how many Cl I have? So I have just the PCl4, right? So what I don't have is this one. So I don't have any Cl here. So this is my hand. So I had something like this. So this is my hand is a P. So this one is a Cl there, and this one is this, like this. So this Cl is this one. P is this one. This Cl is this one. So there is no Cl. If there was a Cl, I would hold like this, all in the plane, right? Make sense? So this is this one is this one, and this one is in the plane, and this one is going up, right up, and this one is going down, right? Something like this. Now there is no Cl here in this plane. There is no Cl. Previously I had a Cl here, right? So one was here, one was here, one was here, one was going up, one was going down. Now in this place there is no Cl, but there are two electrons here. Yeah? Make sense? There are two electrons. Now what happens is that these electrons are going to push this guy this way, and this push everything this way. So they just push everything the other way, right? Now since this chlorine is just bent toward this, so this chlorine is not here. The chlorine here is a little bit this way now. Maybe this chlorine is just pushed too much. This chlorine is just pushed this way, like this one. Everything is pushed away. Make sense? By this, and then this may be pushed a little bit away. This may be pushed a little bit away. Now this shape of this one is distorted. Now it is not 90 degree previously. Previously you say, okay. Previously you said that this is a P. So there was a Cl, there was a Cl, and there was a Cl, there was a Cl, and there was a Cl. So this would push this one. This is there was no lone pair, so it would push. This one would push this one. This one would push this one. This one. So they are very well balanced. And this angle would be 90, and the angle between this one and this one is 120 or something like this, right? But this time there is no chlorine, but here is a more strong force. The lone pair is a more strong force. So this is going to push this one. This is going to push this one, and everything is pushed, and the angle is not 90 degree anymore. So this angle is not 90 degree anymore. Why? This is pushed this way, right? And this is also pushed that way. So not 90 degree anymore. Make sense? So when there is a lone pair, there is no expected value of the bond angle. The structure is distorted. Make sense? Good. So and now what else I have here? Another one. Let's look. I was drawing PCl4 here. This is PCl, Cl, Cl, PCl4, right? Now I want to do only PCl3. I just want to remove two things from here. PCl3. So I put a P here. This is P. Now I have a Cl here, maybe Cl here, Cl here, and Cl here, and then now I don't have other two. I don't have other two Cl, right? Now I want to occupy those by putting some electron here and some electron here. So maybe I just put this a little bit down. Doesn't matter. So Cl, something like this. Now you see 1, 2, 3. There is no chlorine. 4. There is no chlorine here. 4. So this is a PCl3 structure, right? Now previously I have only one lone pair here, and I told you this is pushing this one, this is pushing this one, this is pushing everything away, so this destroyed the shape, right? Yeah. So now there are two lone pair here. Now this is even stronger, more stronger. So this is going to push this one, 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 and then everything is pushed like this, and the shape is even distorted. Yeah. So when there are more electrons in the outside, they push too much to distort the shape. Yeah, good. Now, what else here? Now I'm going to write another one. Let's talk about something like the PCl2. If there is a one, I just write the PCl3, right? Now I'm going to write something like the PCl2. If it exists, I don't know if it exists at all or not, but I just want to give the example, right? PCl2. So I have a P here. So let's put, so you can put the PCl2 is like this. So you can put the Cl here, you can put the Cl here, you can put it here or here also, it doesn't matter, you can put either way. Now previously I had one Cl here, another Cl was here, you could put another Cl here or something like this, right? So you put something like this, and you said, so this one in the plane of the board, this is going up, this is going up, this is 90 degrees, the angle between this one is 120, the 120, that's what we talk in the PCl5, right? Now I want to remove all three Cl. So I want to remove this Cl from here, and then I want to put 2 electrons here. Make sense? So I'm just talking about the PCl2. Now I want to remove this Cl here, and I just put 2 electrons here, right? So I just want to remove this one here, and I want to put this 2 electrons here. Yeah. So there are 3 like this. So now this is like this. So just like this. So you see. So this is my hand P, right? And this one is a 2 electron here, like the P, 2 electron here, 2 electron here, and 2 electron here, like this, right? The plane. Now what happened is that this is going to this one. And this is going to push this one. This is going to push this one. So this is going to push this one. This is going to push this one. This is going to push this one. So the lone pair. So they are pushing each other. Yeah. And then they kind of become balanced. Yeah. So when the pushing is balanced, so there is not much force. This bond and this bond experience. So this is like the linear now, 180 degrees. Make sense? Yeah. So if there was no lone pair in one side, so this would push this too much, this would push this much, and it would be like this, PCl2. So bend, right? But since the pushing of these two is balanced by this guy here, so this may push this one, this may push this one, and they try to bend this one, but there is another force. So this just say, oh, okay, I don't want to push this guy here. So this is pushing this way, this is pushing this way. So the force is balanced there. So this bond and this bond is not get pushed there. Yeah. So like this. So you see. So this is a P. This is a this is the electron. So my hand is a P, right? So this is 2 electrons. This is 2 electrons. This is 2 electrons. So this is pushing this one. This is pushing this one. So they are pushing each other, right? And then so they also push this one, but that force since these 3 are pushing each other and those bond pair, so this one is going up, this one is going down, and that is not effective. So that is just the linear. So if you put, so this is P, one pair electron, another pair electron, another pair electron. So this is one Cl up there, and this is one Cl down here. Yeah. So these are electrons here. Make sense? So this behaves as if there are 3 lone pair along the plane, and there are two other atoms. So once they push each other, it is balanced. The force is balanced, and the chlorine becomes straight line. Yeah, but previously you see that. So PCl2 is like this. PCl2 is like the linear. But if you look the water, so this is the water. So water is like this. So this is a. So let's talk about the water. So this is a hydrogen, the water, and then there are one pair. There is no lone pair here. Only two pair here, right? So there is no another pair. So this will push this one. This will push this one, and then this bend to be like this. That's it, right? But if it was like this, so there was one pair, this is another pair, and this is another pair, it will be linear. Yeah? It's a little bit complicated, but when you practice it, you will get idea. Good. So what else I have here? Do I have here? Alrighty. So now let's talk about another thing here. So this is important for the lab 13 when you go home and you start to practice. Yeah. So actually, they told you to draw the model. How I am showing my hand in this paper. So there are a lot of model people make it and sell it, so that you can just make your own model and see how it looks like. So you can buy the molecular model in the market in $10-20. Yeah, if you want to play around. So. So another one is here. Now let's talk about 2, 4, 6. All right, something like this. I have, let's say, SF6, something like this. SF6, something like this, right? So I have in center S. So this is S atom, and I have how many atoms connected to this one? 6, right? 6. So you can put just like this one. So how you should put them again is that. So this is S. So I'm going to put first. So I put one F here. So I want to F here, another F here, another F here, and another F here. So like this. I put F here. You see that? Now ISF4, right? So how I should look this one is just like this one. So this is the sulfur is my hand now. You see that? The sulfur is my hand now. Now sulfur is my hand. So that I hold like this one, right? Makes sense? So I'm going to hold this one like this one. So that is that one. Yeah? This one. Now I'm going to hold, so let's say this is sulfur. This is sulfur here. I hold this one like this. So this way, so that one. So this one is this one. Makes sense? Now I'm going to hold this one like this one. Makes sense? Maybe I should hold like this one. Like this one, right? Now I'm going to hold this one, another one, like this way. Like this way. You see, so this is like the square or the rectangle you is square, right? Like this, the plane. All are in the plane. So this sulfur is my hand here. So that guy is in this plane. These are all in the plane of the paper. If you hold the paper here, it's exactly, they don't cut the paper. They don't poke the hole in the paper, right? It's a plane. Make sense? Now, where should I put the another two? So sulfur, this is fluorine in the plane, fluorine in the plane. Everything in the plane, right? Like this square. Make sense? Now, where should I put the another two? I should put another one on top of here. So I have here, so like this. This one is another sulfur. Yeah? Going like this on. Make sense? So 5. Now I need to put another sulfur down here. Yeah? Make sense? It's a little bit tricky here, so it's hard to draw in the board. Yeah? So I should hold this one down like this, and then like up like this. So maybe I hold like this one, up like this one. Make sense? So this is a SF6. So this 4, this one is not bent. It's very straight, in the same plane. Very straight, same plane. Yeah? Make sense? So these are square like the plane. So these 4 are in the plane. So this is going down like this. This is going up like this. Yeah? Make sense? Good. So this one. So these are in the this one are in the hand and in the same plane. All are in the same plane. But the two one are, so 5th one is going up, 6th one is going down like this. Make sense? Just like that. So SF6 looks like this. So this is called the octahedral. So this kind of the molecule is called octahedral. Octahedral shift. So this is FF, F, so octahedral. So if you measure the angle, so just like the previous one, so what is the angle between this and this? So this is in the my hand, right? So this one and this one are like this, right? Like this. So this is the phosphorus, this is the sulfur. So this is the fluorine, this is another fluorine, and this is up there is a fluorine. So what is the angle between this and this? 90, right? It's just going up. Make sense? What is the angle between this one and this one? So like this. So these are going like this, and then it is hanging down. So this is like a 90. Between this and this is 90. Make sense? 90. This is a 90. But it doesn't look like 90. It looks like the 30 here, right? So what is not a 30? Yeah? So it's not 30, it's a 90. And then what is the angle between this one and this one? This one and this one. So you held the fourth thing here, like this one, and this one, and this one, and this one. This is 3. Now I'm going to hold this fourth one, and all are in the plane. All are in the plane, like this, right? So there are a 4 angle around a point in a plane, right? So just like you draw the something, a point in the plane of paper, and then equally you draw four ways, right? So total is 360, and then you divide by 1, 2, 3, 4. That's 4, 90. Each angle is how many degree? 90 degree, right? So angle between this is 90. Angle between this and this is also 90. This is also 90. All angle are 90 in octahedral. Yeah, but in how staying right here? So all right, so like that. Now I want to remove one fluorine from here. Yeah, let's remove one fluorine and fill the somewhere with the lone pair electron, right? So I just erase one thing from here. This is not a fluorine anymore. Now I have a two electron here. Make sense? Make sense? Now what happens? So this is no bond anymore. Now this is going to push this one. This is going to push this one. This is going to, everything is going to pushed back now, right? With this one. Make sense? Now, since this pushes with 2 force, this is going to bend this way, this is going to bend this way, this may bend another way, so no 90 degree anymore. Make sense? Yeah? Now, that's a S, I was just talking about S1, 2, 3, 4, 5, SF5, that was SF5. I started with the SF6, now I make a SF5, right? Yeah? So like this. Now I want to erase another one from here. So I want to put one lone pair here in the center atom here, right? Now, even more lone pair. Now, if this is going to push this one, this is going to push this one, and this is going to push this one, this is going to push this one. They are pushing each other. Now they are just pushed with the more force. Yeah? So no more 90 degrees. So this is pushed more, this is pushed more, something like this. Yeah? Make sense? Good. So now let's talk about another one. SF5. So I just talked about the SF4, right? 1, 2, 3, 4. Now let's talk about so let's start with the SF6. S was like this, F was like this. So these are in the plane of the paper. These are in the plane of the paper, right? They're all in the same on the paper. So one was up here, another was one down here. So this is SF6. The angle between this one is this one 90, this one is this one 90, this one 90, this one 90, this one 90, this all angle are 90, right? So you need to hold that molecule like the way. So you just buy a tool, the kit of about $10 in the Amazon, and then you just start to, the sulfur is here, they have the holes, and put that, and you can look there and you can easily see. Yeah. So maybe you are confused with the board, but when you play with the model, it's good. Now and then what I did is, so I told every angle is 90. Now I remove this one, and this one is what? 1, 2, 3, 4, 5. This SF5, no angle is in 90 degree anymore because this is going to push everything. Yeah, another way. So that's SF5. Now I'm going to write the SF4. So you put not F anymore here. So even push more. Yeah. Now like that. Now you may want to put another SF4, 1, 2, 3, 4. Maybe you want to do SF3 now, right? So let's put here another pair. Now even the molecule is distorted. Now put another pair here now. So now SF2. Now I go to SF2. You see that? Now this one are in the plane. So the amount of force they are pushing one way and the other way is exactly same, and this molecules now becomes the linear. Make sense? So like that. So go home and then practice those problem in lab 13, and you, yeah, and then I will tell you how does this two electron come here, how does this two electron, how they come here, how they come here. So how these lone pair and bond pair come here, I will discuss in next class. All right. So I think it's how much time we have? Oh, 45. So maybe we stop today. Yeah. All right, everyone. Thank you very much there. So happy Thanksgiving.
Happy Thanksgiving.
All right.